Hello guys, welcome back to my channel. Now today we're going to be looking at how we can find the square root and the cube root of a number without a calculator with the application of calculus. So let us go right ahead. Now on screen we have the square root of 105. However, we don't directly know that square root, but we know the square root of a number very close to 105, which is 100. We all know that the square root of 100 is 10. So the first thing I'm going to do is to create a function. So we're going to have y equal the root of x. Now we can say let x equal 100, which is a number close enough to 105 that we know the square root of. So y would be equal to the square root of 100. So y would be equal to 10. However, we're not interested in finding the square root of 100. We're interested in finding the square root of 105. Now that is how calculus comes in, because calculus looks at the change of y with respect to the change in x. Now we need x to change by 5 because we want the square root of 105, and if we can find how much y changes by, then of course we can use this to determine the square root of this number. So let's go right ahead. So we have y equal root x, which means we can write it as y equal x raised to the half power. So when we differentiate this, which is the change in y over the change in x, we are going to end up with a half x to the minus a half, which if we refine this, we can say it's equal to 1 over 2 root x. So dy over dx is equal to 1 over 2 root x. Now, what I want is a change in y. So dy is equal to 1 over 2 root x times dx, which is a change in x. Bear in mind that since we want the square root of 105, the change in x would be 5. So I'm going to have the change in y is equal to 1 over 2 times the square root. Bear in mind that x was equal to 100 times the change in x, which is equal to 5. Okay. Breaking this down, I'm going to have the change in y equal, of course, 1 over 2 times the root of 100. The root of 100 is 10. So I'm going to have 5 over 20. 5 over 20 is basically equal to 0.25. So the change in y would be equals to 0.25. So how do I get the square root of 105? What I do is to add the original y value, which was 10, plus the change in y, which is 0.25. So the square root of 105 is approximately 10.25 written to 2 decimal places, and you can use your calculators to confirm this. Now for my second example, I'm going to be looking at the cube root of 30. So just like the first question, I'm going to start by writing my function. So y is equal to the cube root of x. Now, what is the closest number to 30 that I know the cube root of? That would be 27. So we can say when x equal 27, y is equal to the cube root of 27. So y is equal to 3. Now, what we are interested in, of course, is to find the cube root of 30. So we're going to be finding the gradient function. So we start by saying that y is equal to x raised to the 1/3. So dy over dx is equal to 1/3 x to the negative 2/3. This can be broken down as 1 over 3x to the 2/3. So we have dy over dx equal this. Now, of course, what we're interested in is finding the change in y. So we can say dy is equal to 1 over 3x to the 2/3 times the change in x. And of course, moving from 27 to 30 would be a positive 3. So what I'm going to have is that dy is equal to 1 over 3, 27 to the 2/3 times the change in x, which is 3. So dy is equal to, we probably could say 3 over 3. And of course, when I raise 27 to the 2/3 by laws of indices, I'm going to get 9. So canceling out the 3, I end up with 1 over 9. Now, 1 over 9 is a recurring decimal, which I'm going to get 0.1111. So if I go to 2 decimal places, I'm going to get 0.11. So we can now say that the cube root of 30 is approximately the cube root of 27, which was 3, plus the change in y, which is 0.11. So this is approximately 3.11 to 2 decimal places, so to 2 dp. It should be noted, however, that the smaller the change in x is, the greater the degree of accuracy this approach is.